what can all three of those terms evenly divide by? What is it? 2. So we can factor out a GCF of 2, which when we divide that out, we are left with x squared, and then what? A negative 3x. And then 56 divided by 2 is 28. Is that right? Okay. We're going to go ahead and factor this all the way. So this is actually something, so we've taken out the GCF. Now look at the trinomial that you have left. Do you see how this first number is a 1? So this is A, B, and C. Because A is 1, we get to do how we factored on Friday. So you have to find two numbers that multiply to negative 28, but add to negative 3. Multiplies to negative 28, adds to negative 3. What would those two numbers be? Haley and Macy, what are 2?
7 and 4.
Right. Which one's going to be negative?
4.
4. You're right, 4. So 7 and negative 4. Because if you add those two together, you get... Oh, wait, no, that's wrong. You're right. Don't listen to me. It's negative 7 and positive 4. There we go. So when we finally factor this, it looks like 2 stays on the outside. And then x minus 7, x plus 4. So because A was 1, we could do it this way. Then it's fully factored and you're done. Okay, let's move on to the next one. GCF of 3x squared minus 12x plus 18. What can they all divide by, guys? 3. So take out the 3. You are left with x squared minus 4x plus 6. Okay. Two numbers, since A is 1, again, there's no number in front of it. Two numbers that multiply to positive 6 but add to negative 4. Can you think of any? No, that's because you're done. So this is actually your answer. It is factored because you've taken out a GCF. You've factored it with the GCF. You don't need to do anything else because after that point, that middle trinomial is actually prime. So you can't go. But we don't say prime because you have factored it in some sense. Okay, now on to what we're learning today. AC grouping. Just need to remind you about GCFs. This works every single time. This is a process I need you to think through when you're factoring. The only exception is if there's 4 terms like yesterday already, then use grouping. But if it's 3 terms like this every single time, you're going to factor out the GCF like we just did. Do that first. Otherwise, the numbers are going to be larger than they need to be, and it's going to make your life more difficult. It'll still work, but it'll be a little bit more obnoxious. If A is 1 like this, then do what we did on Friday. Just find 2 numbers that multiply to C and add to B and write it out, and you'd be done. The problem is it's not going to be like that every time. So sometimes the A value, or what's in front of x squared, is not 1, and so you can't do it the way that we did on Friday. You have to instead multiply A times C and then find 2 numbers that add to B, and then we'll factor by grouping. We're going to use these steps to help us. It makes more sense with an example. Here is an example for you. Because, look at this trinomial, because it's, so A is 4, B is 7, C is negative 15. A is not 1. So you cannot find 2 numbers that add to negative, or multiply to negative 15 and add to 7. Doesn't work. Instead, because A is 4, and there's no GCF, you have to multiply A times C, so 4 times negative 15 gives me negative 60. And then you use that to think, okay, I need two numbers that multiply to negative 60, but add to 7. And so that would be negative 5 and 12. So you're still finding two numbers, but you gotta multiply A times C first. You'll then split up the B term into those two. So 7x is the same thing as negative 5x plus 12x. And then factor it by grouping like we did yesterday. We're going to do an example, and I promise you it will make more sense. Okay, look at the first one in the back. Here's the problem. It's not 4 terms, so you can't factor by grouping yet. And the A term is not 1. What is it? 3. Bummer. So let's go through the steps, and they're also over here on this lovely poster. Okay, step 1, GCF. Is there a GCF between 3, 14, and negative 5? No. Move on. Is A equal to 1?
No.
No, it's 3. Is A not equal to 1? Right, it's not equal to 1, so you're going to multiply A times C. A C is 3 times negative 5, which is negative 15.
What about the variable?
We are just doing the numbers in front. So when I say A and C, I'm just talking about the coefficients. Ignore the variables. Okay, so that is your A times C. Next step. Look over here. Find two numbers that multiply to AC and add to B. So just like you did the other day, but this time we're using A times C. So two numbers that multiply to negative 15 but add to 14. Can you please discuss what are those two numbers? Go. One of them is going to have to be negative. Could someone tell me, please? You can raise your hand. What are my two numbers? Manola, what are they? They are 15 and negative 1. Okay, great. Those are your two. Next step, if you look over on that poster, step 5, split the B term using the two numbers you just found. We are not changing this polynomial. The B term has to add up to 14. We know two numbers that add up to 14 are 15 and negative 1, so we can rewrite this polynomial as 3n squared. Okay, which number makes more sense to put with 3n squared? 15 or negative 1? Which one has more in common? 15. We're going to end up factoring by grouping. You want to put the things that have most in common. So 15n should go with the 3n squared, because those have more in common together. And then we put negative 1n. The C term stays the same. All I have done is split up this B term, 14n, into two pieces here, which add up to be the same thing. Okay, now you factor by grouping like you did yesterday. So it's already grouped nicely for you. We already put the numbers in places that make sense. So literally do the same thing you did yesterday. And the same thing you did for your warm-up. Group those two, make sure there's a plus sign in between, and find your GCFs. What's the GCF of the first one? No. 3n. They both divide by 3, you're close. 3n, which if you take out 3n, then you have n plus 5. Okay, plus sign in between. We need this to match, right? What do you have to take out the second one? specifically negative 1. That way it ends up being n plus 5. Good. So take out minus 1, and that would leave me with n plus 5. And then just like yesterday, you end up with 2 parentheses, 3n minus 1, and n plus 5. Double check. Last thing, is it fully factored? Is there anything else that you can factor out? Like any other GCFs? That's it. So the only thing that's different is if a is not 1, multiply a times c and use that to get your two numbers. And then you factor by grouping. We'll do the next one. We're going to ask yourselves each step. First thing, number 1, is there a GCF? No. Bummer. Number 2, is a equal to 1? No. A is equal to what right now? 4. So you are going to have to multiply a times c. So you are multiplying 4 and 5. So AC is 20. We need two numbers that multiply to 20, but add up to what? Negative 9. Because we're going to have to split up the b term. Okay, please find your two numbers. Joe on the back. Carson, what are the two?
-4, -5.
Bingo. Next step, split the b term. I'm looking at the poster, it's also on the front of your notes. Split the b term using the two numbers you just found. So take negative 9, and instead of putting negative 9, you're going to put negative 5, negative 4s. So it's still 4s squared. Let's think about this logically. Which number has more in common with 4s squared? Would it be the negative 5 or the negative 4? The 4. So put negative 4s, then negative 5s, and plus 5. I will let you do the rest of this problem. I need you to factor by grouping. Go. That's really the hardest part. If you can get to this part, since you know how to factor by grouping, it's easy living. Because in your second parentheses, because it starts with a negative, you should take out a negative. So instead of just taking out 5, take out negative 5. So check your final answer when you have it. S minus 5 and s minus 1. You have one more. Let's go through the same steps we've been doing. Step 1, is there a GCF? You bet there is. Can you please figure it out? I want the largest number that all three terms divide by. If you're not sure, then use your calculator and guess which one. Calculator, guess which one. What's the largest number that all three divide by?
4.
Is it 2? No, they all divide by 2. What's actually the largest number they all divide by? 4. So factor out a 4. Because that's going to make your life a heck of a lot easier. If I factor out 4, then I have x squared minus 4x, and what's the last one? Thank you. Before we move on, we need to check, are there two numbers? Hold on. Is a equal to 1? Yes. This number right here is a 1. So we could just find two numbers that multiply to negative 14 and add to negative 4. Are there any? No. So you are done. This is your answer. You take out a GCF, and that's all you can do. Because there are no two numbers that multiply to negative 14 to add to negative 4.
So if it is a 1, or if it's like the 1 thing, does that mean this method does not work? Like if it's equal to 1, does that mean it does not work?
You can still multiply A times C and do it the other way, and it will work. Yeah. So if you forget and you don't notice that A is equal to 1, and you just go ahead and factor by AC grouping, it will still work. It's not a problem. It works every single time. I'm not kidding when I say that.